Hi everyone. Today we're going to study sum of geometric sequence. First, let us define geometric series. If a sub 1, the first term, the second term will be a sub 1 times r. The third term is a sub 1 r squared. The fourth term is a sub 1 r cubed. Up to the last term, a sub 1 r raised to n minus 1 is a geometric sequence where a sub 1 is the first term and r is the common ratio. Then the sum a sub 1 plus a sub 1 r plus a sub 1 r squared plus a sub 1 r cubed plus up to the last term a sub 1 r raised to n minus 1 is called geometric series. Let us now discuss formulas for geometric series. The first formula is for infinite geometric series. The formula is S sub infinity equals a sub 1 over the quantity 1 minus r. A sub 1 is the first term and r is the common ratio. There is one important note here that the absolute value of r, the common ratio, must be less than 1. Letter B formula is for finite geometric series, and the formula is S sub n, that is equal to a sub 1 multiplied to the quantity 1 minus r raised to n. The n is the number of terms, all over the quantity 1 minus r. Let us have examples. Example 1. Calculate the sum of infinite terms of the sequence. The first term is 1. Second term is 1/3. Third term 1 over 9. And fourth term 1 over 27. So on and so forth. Because of the word infinite here, we are going to use the formula S sub infinity, that is equal to a sub 1 over 1 minus r. But take note that the absolute value of r must be less than 1. Let us now collect the required value for the formula. The first is a sub 1, the first term, and that is 1. Next is r, the common ratio, which is not readily given in the problem, but we can solve for r. We will take any two consecutive terms, putting them in a ratio, and this ratio must be common to all pairs of consecutive terms. Let's begin with r equals a sub 2 over a sub 1, and that is 1/3 all over 1, and this is equal to simply 1/3. Let us take another pair, that is a sub 3 over a sub 2, and this is equal to 1 over 9 all over 1/3. Let us show now that this is 1 over 9 times the inverted fraction 3 over 1. So we can cancel the 3 and the 9 down here, and this is also equal to 1 over 3. The last pair of consecutive terms is a sub 4 over a sub 3, and this is equal to 1 over 27 all over 1 over 9. So let us multiply this 1 over 27 into the inverted fraction 9 over 1. We can cancel this 9 and the 27, and the simplified form is also 1 over 3. We can see here that the ratios are common, and that is equal to 1 over 3. So we can write the absolute value of r is 1 over 3, and take note that this is less than 1. So we can use our formula here. And then let us write this value in our blank opposite the r on this side. Then let us start solving for s sub infinity. Substituting the values, this is now a sub 1 is now changed into 1. The r is now changed into 1/3. Let us simplify further. Let's begin with our denominator. This whole number 1 we will convert into a fraction that is with the same denominator with 1/3. So what we'll do is to multiply this 1 with 3 and put the answer in the numerator of the fraction here. All over, we will simply copy this denominator 3 in here. So we have this value 1 is equal to 3 over 3. And then we can see now that our denominator has difference of two fractions with same denominator. So we can simply operate in the numerators, and that is 3 minus 1, and that is 2 over 3. And then let us invert this 2 over 3 into 3 over 2 to be multiplied with the numerator 1. So 1 times 3 over 2 is simply 3 over 2, or we can write 1.5. This is our final answer. Let us have example 2. Find the sum of the first 10 terms of the sequence. First term is 2, second term 4, third term is 8, fourth term is 16, so on and so forth. Since we're going to find the first 10 terms, we will use this formula S sub n equals a sub 1 times the quantity 1 minus r raised to n all over 1 minus r. Let us list the required and given values. The first is S sub 10. This is the sum of first 10 terms that is required in the problem. Next is a sub 1, the first term, and that is 2. The r is not yet given. We will solve for that. And the n is the number of terms, and that is 10. So let us now solve for r using any two consecutive terms in our sequence. Let us also try to see if the r is common in any given consecutive pairs. Let's begin with a sub 2 over a sub 1. And this is equal to 4 over 2. And 4 over 2 is equal to 2. The next pair is a sub 3 over a sub 2. And this is equal to 8 over 4. And 8 over 4 is also 2. And the last pair is a sub 4 over a sub 3, which is equal to 16 over 8, which is also simplified into 2. We can see here that the ratios are common, and we are sure that this is a geometric sequence, and we can use our formula here. Also, let us copy this value in our blank here. So r is equal to 2. Now, let us begin with our solution for s sub 10. And using our formula here, let us substitute the values. So we have a sub 1 is now 2. And take note, the r, or the common ratio, is used twice. One in here, also in here. So we have 2 times the quantity 1 minus 2 raised to 10 all over 1 minus 2. Let us simplify this 2 raised to 10. Using our calculator, we have 1024. In the denominator, the 1 minus 2 is simply negative 1. Let us simplify further. These numbers inside the grouping symbol, 1 minus 1024, will be negative 1023. Let us get the product of this negative value and the number 2 outside. We will get this negative 2046. And we have negative divided by negative. The answer will be positive. And this is negative 1 in the denominator. So simply we can write this 2046 positive. This is our final answer as the sum of the first 10 terms of the given sequence. I hope you learned something from this video. See you again next time.